Okay, in this section here we're going to be finding the derivative of an inverse function, and actually we're going to be evaluating it at a point. So the first thing I'm going to do here is I'm going to draw up a picture for us to look at and put a dotted line here. Okay, so I'm going to attempt to draw a picture, and we're going to label this as our function f of x, and then we'll give this a darker color, some different color, and we're going to label this as our inverse. Okay, so this line here is f of x, and this line here is f inverse of x, the inverse. So when we're talking about taking the derivative, first off, on some interval here, it must be the continuous. Our function has to be continuous, and it must be differentiable at every point. And also that f must have an inverse. Okay, f must have an inverse. All right. Let's say that I pick a number here on the x-axis. We'll call it a, and we'll call this b. So in other words, f of a is equal to b, and I'll write that as an ordered pair over here, ab. And so f inverse of b should equal a. Okay, that's what it means to be the inverse, and then b a. Okay, so in other words, I plug in f of inverse, which is going to be this function here, and it's supposed to be a perpendicular line to the dotted line. Okay, so if I were to plug in b, which is about right here, let's say, okay, and then we would get out a. Now here's the interesting thing. If I took the derivative of f and I were to plug a in, we're going to say that the slope of that tangent line is equal to m. Okay, so that would be the tangent line if we're going to draw a picture to this thing. The derivative would be equal to m. Now what's interesting here, that's supposed to be a tangent line. It's not a very good one. This guy here, the other tangent line, alright, what would this slope of this tangent line be? Well, it turns out that the derivative of the inverse, and of course we'd be plugging b in right here, would be 1 over m. That's right. So all you have to do is find m and then just take its reciprocal, and you have now found the derivative of the inverse at b. So the idea here is they're going to be giving us b. We need to find a. Once we find a, we can take the derivative of the function they're going to give us and get out m, and then we just take the reciprocal. Okay, they're going to give us b. We're going to have to find a, plug a in the derivative, get the derivative, and then take the reciprocal. That's all we have to do. All right, but the tricky part here is figuring out what is a going to be. Okay, what is that number? That's going to be the tricky part right there. Once we get this number, then the rest of it's easy to do. All right.